Okay, welcome again. We appreciate everybody's attendance today for this webinar entitled Ensuring Safety and Security, Navigating the Cyber Challenges in Connected Cars and Autonomous Vehicles. I want to welcome everybody and just cover a couple quick housekeeping items before the panelists join us. Two things really to get started. The first is everybody is muted, but feel free to add any questions as we go throughout the discussion. We'll be monitoring the chat, so if you post some questions there, we will do our best to ask those at the end, and in some cases even work them into the discussion if they're captured timely, at the right points. But we'll certainly capture those questions at the end, so please share in the chat. Also, we will have time for a Q&A session at the end, but after the session, we will be sending out the webinar recording and a couple slides and a couple highlights from today's webinar. So with that said, let me get started. We'll begin, just covering a couple topics. I have three stats here. And as you think about, automotive cybersecurity generally, we recognize that there are safety requirements. We recognize that there's a complex supply chain with many vendors contributing technology that has software on it. And there is a significant rise in connectivity in the automotive industry over the past several years. And with that, we have some stats about 2024 automotive cyber attacks. And there's three numbers, 92, 70, and 35. And to just kind of say what they are, did you know, and this is based on the 2025 Automotive and Smart Mobility Cybersecurity report that just came out February 13th. Did you know that 92% of those attacks were remotely executed? And 70% of the cyber attacks in 2024 in the automotive sector and the connected devices to automotive could affect thousands or millions of devices. And 35% of those exploits were involved in some form of car system manipulation. And so I can't think of three better stats that suggest why cybersecurity in the automotive industry is very, very important and why RunSafe focuses on it. And just so people know what RunSafe does, we offer the RunSafe Security platform that helps you identify security risk across your supply chain and then protect that code from and prevent exploitation while monitoring software. And with that, what we ultimately do is through automated exploit prevention, we can help you reduce 99% of your zero-day risk, as well as the prevention of a majority of your vulnerabilities in your code. And with that, we also offer for today's attendees a free risk reduction analysis on your software, including your software coming from your supply chain, whether that's open source or partners you work with. So without further ado, and I'll put this slide back up at the end, but if you wish to send me an email, you can note it now. But without further ado, I'd like to welcome the panelists to join me. Okay, welcome Jose, welcome Scott, welcome Doug. We really look forward to the conversation today. What I might ask is just each of you take 1 minute to introduce yourself. Scott, let's start with you. You've got the floor for 1 minute.
Sounds good. Well, thank you, Joe. I'm excited to be here with the webinar and talk about one of my favorite topics, automotive cybersecurity. I have a background coming from the original equipment manufacturer, or OEM. I've worked with Ford, I've worked with suppliers, and now with Rustic Security, I help OEMs and tier ones do comprehensive risk management for automotive cyber. So really excited. I think this is a great topic, and I enjoyed those stats that you had on the screen. I think the industry has still a lot to work on. There's a lot of progress that's been made, but still obviously a lot to keep safe in the vehicle. There's a lot of computerized components, so a lot to secure.
Thank you for being here, Scott. And Jose Shumosh from Critical Software, please introduce yourself.
Hi, Joe. Thanks a lot. I'm Jose. As you mentioned, I work for Critical now almost 18 years. My background has been mostly technical, as a software and systems developer, and the past few years I've been acting as business development manager for the automotive market. And even though I'm not a cybersecurity expert as the rest of the panelists, I know a thing or two, and I know the market a little bit as well. So that's why
You're very
I'm
modest,
here.
Jose. We really appreciate our partnership with Critical Software, and certainly you. Also joining us is Doug Britton, and I would just want to say one thing. Many people may be aware in the 2014, 2015 timeframe of the Jeep cyber attack that got a lot of publicity. Doug had worked with an incredible cyber security research team that he managed. And I think it's going back to 2011, 2012, with the government, with some manufacturers, with some OEMs. Doug and team demonstrated ways you can remotely control cars. Not the same publicity that was done in 2015, but certainly very, very important from the evolution of automotive cybersecurity. So I snuck that in because I figured Doug probably wouldn't even mention it. But over to you, Doug, to introduce yourself.
Thank you, Joe. I'm excited. One of RunSafe's founders, and I got excited about kind of undertaking the set of problems that we focus on because we wanted to be able to rewrite the economics of defense. We know that our adversaries outnumber us, 50 to 1, 100 to 1, depending on how you count, and and if we try and fight the same fight again and again, we're just going to lose. We need high scale solutions that allow us to get out of the challenge of chasing bug at a time. We need humans to be able to act, thousands of times faster. And so, that's what got us excited, and so I'm excited to be able to show ways that could be meaningful in the automotive.
Thank you. And thank you to all the panelists. And again, for the audience, should you wish to ask questions throughout, please prompt those. But I got my first question here. So with that, welcome to the panel. And I'd like to start with another report that came out in 2023. Cybellum issued a report that revealed that there were over 5,900 new CVEs in automotive software in 2023. So my question really for the panel is, how are these vulnerabilities impacting the industry, and what strategies are manufacturers employing to address them?
So one of the things that we're observing is, there's now taking form in procurements at, the need to weave security requirements into procurements. And so that's one of the ways that that's taking shape is, learning from other industries that have already had to flow requirements down to vendors. And there's some bristling at different stages of the stack because some of the tier 2, tier 3 vendors have not had to provide cybersecurity before, and so that's got some head scratching and some bridling, but also people are trying to figure out how to take cybersecurity solutions that have been effective in other parts of the economy and see how they can be shoehorned into automotive. So that's one set of observations.
Yeah.
Jose or Scott?
Picking out what Doug was saying, and there are more or less two worlds right now in automotive, one that's very cloud dependent and another that's very edge dependent. For the first one, there's a lot of stuff already done and developed, so there's a lot of reuse potential for cloud part. For the edge, most of the industries are still learning a lot on what to do, because devices are connected since a few years. Or they were connected, but they weren't seen as threat vectors. And now they are being seen as threat vectors, and so I guess that on the edge side, everybody's still learning a little bit on what to do.
Scott?
Yeah, and I think just for some comments there, as Doug had said, the whole supply chain is involved. As of the last 10 years, with the standard of ISO SAE 21434. That's really gotten the whole supply chain involved, where the OEM is helping to lead the risk management for their vehicles. And they have to be aware of these vulnerabilities, like you're saying. They crop up in different areas. I did bring a slide I'm going to share real quick. If you guys can let me know if you can see this. The CVEs that are affecting the automotive industry come in a couple of different areas. I brought two examples from the past 2 years. CVE 2023 29389. This is some friends and connections on LinkedIn, Ian Tabor and Ken Tyndall. So they were able to reverse engineer a device that they had found that thieves were using this exploit on the Toyota RAV4 architecture to steal the vehicles. So this example is to show vehicle architecture is really impacted by these CVEs, and Toyota is having to really, vehicle architecture is a slow development process, can take 4 to 5 years. So this one was an example of in 2021, but you can think that was engineered probably 4 to 5 years before that. They're able to take out the headlight, plug into the CAN bus, send this key is valid message, and then they could drive away with the car. It was an immobilizer bypass, and again, really impacted the OEM architecture. The second example is CVE 2024 23923. This talk I watched this last week. There's a great explanation of all the research that went into it. This is Mikhail Evdokimov from Hungary. He works with PC Automotive. They have a zero-click remote code execution on the infotainment unit that they were researching for Pwn to Own. And he shows all the intricate steps to be able to do a pre-authentication Bluetooth takeover, pop a remote shell, so the infotainment would connect to his rogue access point. He did this all over Bluetooth. And again, it shows an impact at the ECU level. The whole, like we're saying, these two examples, the architecture and the ECUs have to worry about these CVEs. And it's really changing. It's kind of like a cat and mouse game. You are reactionary in some aspects. You don't know that these CVEs are going to happen. You don't know what the impact's going to be, and then you have to react. So I thought those were two interesting points to bring up.
Yeah, and those are two really great points. Over to you, Doug.
Yeah, and I'll just end on this thought. Like what Scott gave is just a perfect example of the conundrum that the automotive industry and other things like aerospace and defense, where you have these assets with multi-year device design life cycles that are going to last for decades. You need to find solutions that are going to be resilient in the architecture to these future unknowns. And if the architecture hasn't contemplated these future unknowns, then you're going to spend 20 years playing defense.
Yeah, and and even you have to plan for those 20 years of life cycle, but you also have to plan to continuously update for those 20 years of life cycle, because if you decide to use, I don't know, version X or Z of said operating system right now, though that will be discontinued sometime in the future. So you have to plan for keeping the versions updated during the life cycle of the vehicle and keeping continuously developing and integrating new solutions.
Absolutely. And as I noted, it's over 5,900 new vulnerabilities, which is a lot. And we had a question from the audience. Srinivas asked, how can we we try to filter out all these. What's the most efficient way to do these? What I would offer up, and others can confirm, but one way, Srinivasa, for when you say you have a pretty extensive search criteria to look for these, one way to search for them is by associating it with your software bill of materials and look for precise components and how they match. But certainly, part of the challenge in all this, which is something RunSafe is involved in working on, is how do you include better matching of components and better reporting of those components and versions. So those are challenges, but I do think associating an SBOM with those and having the CVEs associated with that, and then using that SBOM to monitor is a great way to do that. Okay, so let's jump ahead to the next question. And certainly, Scott, thank you for those examples. And I guess can the group expand on any other recent examples, real world examples of cyber attacks, just to bring some of those home for the audience today?
Well, there was recently an issue with the Volkswagen Group where data was freely available on cloud. Location data, you can even identify specific vehicle owners, and there was some high-profile vehicles there from heads of state and similar. So it's borderlines on national security. There are more funny things like a guy with a stop sign on a t-shirt that's stopping autonomous driving cars. That's more colloquial, but nonetheless, it's a security issue because you can override specific programming and stuff with things that are very out of the box. So,
Doug or Scott? I do know infotainment is one area that was reported recently. One OEM reported, some vulnerabilities in the infotainment system, and it's really no surprise. There's a lot of connectivity based on infotainment systems, some known vulnerabilities, and I think Mercedes-Benz reported some in conjunction with Bosch, just in the past month, what some of those vulnerabilities could ultimately do.
Joe,
yeah, please.
I just
Scott.
had another quick example. Last year, I was able to go to Tokyo for Pwn to Own Automotive, and it was my first time in Tokyo. I enjoyed the food, loved seeing the demonstrations of the exploits that these researchers had brought to show how they could take over. One was a group from France, Synactive. Last year, they won the competition, but they were able to show from the cellular connection a modem takeover. So again, similar to like we're referencing the GPAC from 2015 as such a pivotal point in the industry. It's not like these remote and connected attacks aren't still taking place. So that was last year. They showed, of course, with the non-disclosure, it's not like they were giving all of the public details of the modem takeover, but they did show they showed that they're able to remotely get onto this and root this device. And they presented that. I just thought it was interesting to see, these things aren't as far fetched as, as maybe Hollywood is presenting. It's those things can happen.
Yeah,
it's a great point. Please, Doug.
Another thing, when earlier in my cyber career, we were working on, the national security defense side, and when you let your mind run a little bit and you contemplate a well-resourced attacker, especially building on the example that Jose mentioned, it's not far-fetched to contemplate that you would, if a foreign adversary or foreign criminal element is able to just simply use cars as a surveillance network. I mean, you free the criminal element or the foreign intelligence service from the need to have boots on the ground in a particular area to monitor, because they simply, let's just let the car do the work for us. And
Yep.
That's imminently possible. It's been demonstrated, and our adversaries are well resourced. Will definitely continue to spend time and effort in being able to mine that information.
Yeah, absolutely. Well, let's jump ahead to the regulatory landscape then, because that has a big effect on safety and security. And generally, how are automotive manufacturers, or specifically, how are automotive manufacturers adapting to the EU Cyber Resilience Act, UN R155, ISO 21434? What challenges are they facing in implementing such regulations?
Well, Cyber Resilience Act doesn't apply specifically to automotive because they defer to UN R155. And there, it's something that's been for the past few years already in place for new models. So I think that the transition went more or less smooth. It's not that different from other standards that exist. It's just a matter of being specific to cybersecurity. So instead of having an hazard analysis like in ISO 26262, you get a threat analysis, and then you derive requirements and protection measures and all those things from there. I think it's mostly in place, or at least in the big OEMs, it's likely in place, because as Doug was mentioning, cars are a very interesting asset. And you can monitor a lot, even outside the vehicle, because most cars nowadays, or at least the high-end ones, start to get noise cancellation from the outside and stuff like that. So you can even monitor the outside of the vehicle, not just the inside. Most of them have cameras everywhere, so you can record a lot of different things. And yeah, I think that was.
And I know, Doug, you've been working on 26262 and ASIL related topics. Any comments there on the regulatory side?
Yeah, one of the things that the automotive industry is contemplating is, many of the questions that are now becoming the everyday parlance of cyber practitioners in automotive have their roots in problems that have been solved or addressed in other parts of the cybersecurity industry for the last 20 to 30 years. The challenge, and this is an appropriate challenge, so this isn't a statement critical of the automotive industry, but is that, the things like ISO 26262 act as an air brake or a handbrake on the ability for some of these technologies to make their way into ECUs and other aspects of the vehicle, and appropriately in many respects, because we need, when you press the brake needs to activate, so you need the rigorous methods of 26262 to ensure security, or to ensure safety. But what is then still important is, finding ways, getting, really mastering the nuance of these processes, and finding ways to bridge existing technologies that solve many challenges that the industry is facing into the safety certified space. It can't be done. There are areas where that dam is getting pushed back, where we're able to make progress in that. And so I think that's hugely important.
Very good. Before I continue with my questions, I have a question for the audience to chime in. As I mentioned, Srinivas has talked about SBOM and even talked about the proprietary nature of code in the automotive industry, where it may be hard to identify some of the CVEs if they're not reported. And then Lucretia mentioned some things about third-party risk. What I would ask everyone in the audience, if you would, please send in a couple messages. What are your biggest challenges in the automotive cybersecurity realm your organization is facing? We'd love to see those, and we'll adapt some of our responses to those topics as well. And what I would say, Srinivas, is with the proprietary nature, there's other ways to analyze code. And so if you look at all the software you're getting, what is the risk for exploitation? What's the risk of 0 days? And there's other techniques I think you can do on the software binaries you're working from to identify even further risk that could be reduced through cyber means. So please, everybody out there, please share one or two thoughts you have on challenges in the cybersecurity realm that you would like for us to cover, and or just for the benefit of the group. We'll share some of these as we go forward in the following minutes afterwards, or at least the meeting notes. With that, let's jump ahead to future trends in automotive cybersecurity. So with the rise of software-defined vehicles, what new security challenges and opportunities are emerging for manufacturers?
Joe, I've got a slide on this one, if you don't mind if I share
yeah,
again.
let's do it. Please.
So this comes from a very interesting OEM, Rivian. In their 2024 Investor Day, they were going over, these are some of the stats from their recent developments from switching from more of a domain controller architecture to a zonal architecture. Zonal meaning there's like a north, south, east, west zone of the vehicle, and you have ECU consolidation to cover the different functions that these domain controllers or domain, like a body controller would be replaced with. Instead of those lights being controlled all to the body controller, they might go the light closest to the north zonal controller would be going to that. And so you reduce, as you can see the trends on here, you have ECU consolidation from 17 ECUs down to like 7 from their Gen 1 to Gen 2. Going to that zonal architecture, you have harness length reduction, so reduction in weight and cost for your electrical harness. And then also your electrical bill of materials are becoming much cheaper as you consolidate. Now on the security side, that also means you have security consolidation. You have less ECUs to secure, but you need to secure them. You can dedicate more resources to securing them. Your middleware and your like maybe APIs that are going in between this zonal architecture from one zone to the next, you definitely have to secure that backbone of communication. It just means you can focus more of your efforts on securing those ECUs instead of having like the old model was an ECU per function. And then you think of all the security features as an engineer, I was over some of those where, you know, I'm coordinating secure boot, secure software update, diagnostic security, all these things that you multiply those across the ECUs. And I think the ECU consolidation really helps security.
It's a really, really good point, Scott. You know, and what it reminds me of is, you know, we have seen an evolution of cars going from maybe a car with a bunch of individual computers to a software system that has wheels, to your point. And that overall decomposition or resetting, if you will, does come with opportunity to boost security, just as you say. Other trends, Jose or Doug, that you're seeing?
There's a lot of investment also in virtualization and hypervisor technology to get use to extract the maximum of reducing the number of controllers inside the vehicle, so a lot more powerful computing units, which will run containerized solutions for the different software solutions. It's also a way of mitigating risk because containerization can provide a separation of domains and features, and so even if one is not working properly, we can reduce the risk of affecting the others. And at the same time, more software is being introduced and a lot of open source, where we all know that CVEs are popping up every day. And so a CV, let's say an Android or something like it, will affect millions and millions of vehicles very easily. And that's also a risk.
Any other trends, Doug, you'd like to highlight?
Yeah, and we've already talked about it a little bit, but it's maybe worth calling out here. You know, the amount of data for a user that is cloud-based, you know, that is off vehicle is kind of hard for the lay driver to comprehend. I mean, they get in, actually don't turn a key, they press a button, they go, and you know, gigs of data about them and everything about vehicle performance and interactions with subsystems and things like that is getting accrued. And so it's interesting to contemplate that, you know, in the future, you know, car as a service kind of things, you're not going to buy a car, you're going to license a car. That's a weird idea. You get a right to use a car in a certain framework. Well, wait, no, I own the car, right? Maybe. So that's compelling you know, a bunch of contemplation in law around privacy, around who owns, you know, what is your right to that data, and so it's a really interesting set of challenges.
Well, building on something Jose mentioned, which was the open source software being introduced, and certainly the increase in number of suppliers delivering software or software components and some major software vendors, including operating systems and the like. There are, a lot of questions around the frameworks for cybersecurity and building resilient systems. And so, are there best practices, or what best practices can be adopted to maintain production continuity while adhering to new cybersecurity standards and kind of maintaining control and safety and security over a complex software supply chain that could include not just open source, but even more suppliers? So what are some best practices around the of a cybersecurity framework that folks are seeing?
Okay, well, there's the software factory domain or topic where most OEMs are trying to reach out to a continuous deployment or DevOps environment as close as possible, so that I don't know, every day or every few hours there's a production ready build. It still has to go through the regulatory aspect of homologation and all those kinds of things, but that's something that's important because it allows quick reaction time in case there's some issue that you have to fix quickly, but that implies knowing all your supply chain. As we were talking a little bit about, and not just your supply chain, but the one from your suppliers. So if you buy an ECU from tier one, the issue might be also in that ECU, and you have to understand their quickness to respond for you to be able to respond as well.
Scott?
I'd say some of the best practices, well, and trends I've also seen are the OEMs are much more wanting to control their software, right? We're talking about this move to a software-defined vehicle where there's value for the OEMs to push software updates across a vehicle architecture and not have to. The comment from RJ Scaringe back to that investor day was they had to own the ECU software because otherwise they'd be contacting dozens of companies. Hey, we want to put a new feature on, and that's the old model. The new model is much more agile as far as I have a friend, another consultant, Florian Road. He does a lot of software-defined vehicle consulting, and his take is you have to have a lot of hardware in the loop based tests that once you, let's say you find a CVE during development, or there's one that affects your bill of materials for the software. Now, how do you requalify or the homologation test for that vehicle? If you have a system of automated V&V, verification and validation, where some OEMs do, they're practicing this much better than other OEMs. They can push out this candidate software with a patch. It goes down to vehicles that get tested in certain fleets that are test fleets, and then they push it out to the rest of their vehicles. Again, that you can see across the board, this is going to be a future distinguisher amongst security quality for these OEMs. Who can do this the quickest? Because I think, as Doug had mentioned, like you have these actors, these threat actors that are attacking, and it's not like they're going to wait on the OEM. So how quick can the OEM respond? And again, what are their subsystems? Have they automated the V&V process so they can quickly retest and requalify software?
And Doug, any other?
Yeah, and I think one of the key things that the key best practice really is looking at whole of class, whole of vulnerability class, architecture and business process changes. So if you architect well, and deliberately, it's very possible to find yourself not in the rat race around individual CVEs, but being able to get ahead of that with known, sorting out entire classes of risk, memory safety risk, and other things like that can be entirely, tied off, and the criticality of those driven basically down to zero. So I really keep, that in mind, because then you're not playing defense with your customers when new vulnerabilities are coming out. In a world where cybersecurity is a consumer level question these days, like being able that there's an opportunity for differentiation in the supply chain and with customers, particularly as autonomy comes in. I mean, it doesn't take a science fiction movie to understand what happens in a fully autonomous vehicle when someone else is controlling it like that. I mean, that's a scary thought.
Absolutely. I'll just we do have a couple questions coming in that we will shift to audience questions here in just a minute. So if you have a couple others at top of mind, please send those. I see Sagar and Lewis have some questions. We'll get to those. But I have a couple impromptu questions for the panelists. Some of the ones we asked earlier were prepared, and I always like adding in some of the impromptu ones. So one of them is building on something, Doug, you mentioned about autonomy and autonomous driving. And I'm curious from each of you, are you more concerned about autonomous driving or infotainment from a security perspective?
So, I would say I'm more concerned about the autonomy because again, it's easy to envision the worst case when you've lost when someone else is driving your vehicle and you don't have a chance to shape that.
Yeah, I also feel like probably infotainment is a prime candidate for exploits, but of reduced risk, and autonomy will maybe not so easy to exploit, but the potential risk is a lot bigger.
Where do you stand on that, Scott?
Yeah, I'd say I agree. I'm more concerned about autonomy. I come from a background. I was over a cybersecurity architect for an ADAS controller, and I know a lot of there's a lot of security that goes into securing autonomy. Then I did have a stint at Neuro where they were making autonomous vehicles, and seeing how those vehicles get secured. There's a lot of security that goes into making sure, that those systems, like Doug was saying, ASIL rated for safety, 26262, and cybersecurity rated so that you can't take them over. Generally, like you had mentioned, the architecture is such that the infotainment, has a lot of nice, interesting remote attack vectors, but it's generally segmented off from the core powertrain components for a safety reason, right? And security reasons. But noting, I will say from that Rivian architecture, as I was reviewing their architecture, they did re-architect to include the infotainment and their autonomous drive computer in the same package. I'm sure there are plenty of security. Obviously, I don't know all the details. Plenty of security measures taken, but that, like you say, that mix of segmenting out the user experience, which might have more privacy issues on the infotainment versus the safety issues. I mean, I'm going to pick safety issues on the autonomous driving every day.
Yeah, certainly because of the consequence and given the focus on safety for good reason. I know Doug has said multiple times in the past he's always grateful it does take multiple years for a new model year to come out. You don't want it to be introduced in a day. And certainly the consequence is high. So let me ask a follow-up question to that, and then we'll get to audience questions. Are you then pessimistic or optimistic about the safety and security of autonomous vehicles? Because we said we're more concerned about that. Are you optimistic or pessimistic about industry's ability to do a good job on safety and security?
I'm optimistic that it can get there. The economics driving it are huge. I mean, the economic outcome of it being achieved successfully are huge, and so I think the resources will be there to make it happen. So I'm optimistic.
Yeah, I'm also an optimistic guy when it comes to technology, so I'm also optimistic. And it will be a stepwise approach. there won't be a full self-driving car next year, like the other gentleman keeps saying. But there will be stuff that will be automated, and those small stepping stones will give us enough time for doing the thing properly with safety and security in mind, I'd say.
Very good. How about you, Scott?
I think, yeah, just what Jose just said, the combination of safety and security in the autonomous realm is really the key aspect. Those redundant controllers, you have the advantage of at a hardware level, knowing at hardware, I can take safe control of the vehicle. And not only, it's not just a speculation, I have verified that with my engineering tests, right? So you run all sorts of scenarios where, if you were to, let's say, compromise a certain level of the vehicle, when do those safety systems kick in? And just like any safety system, right, you have to have assurance that it's going to kick in and do the right thing when maybe, yeah, those faults, whether it's hacking or whether it's just a glitch maybe in the software, that you have a assurance case that you're going to have a safe system. So yeah, very optimistic, and I look forward to that future of autonomous driving, a lot of autonomous cars all over. I'm optimistic about it.
Very good. So we're going to shift to audience questions, but I do want to highlight a comment that George Nunes shared with us, which I think is fun as we assemble some of the other questions. So he wrote that there was a case during the development of Tesla where they found if they played the original sound of Super Mario, an ECU would open a free communication port due to a feature in one of the libraries they were using. And there may be some other Easter eggs scattered around. And so I guess that's a confirmed item that George shared. And I think we've seen that. There's always the possibility for cute little Easter eggs, but it is also a reminder of some of the security things and some of the risk in the supply chain. And it gets to testing and other things you can do, to help minimize the effects there. So, okay, so we'll shift to some additional audience questions, and whoever wants to answer this, please step forward. I'm thinking this might be Jose, but I'm not sure. Maybe Scott. In case of autonomous vehicles on the road, vehicle-to-vehicle communications is crucial and necessary in the future. And so security is a key aspect to play for. It has a key aspect to play for this. Are there important considerations to avoid breach or standards that we should be thinking about when we're thinking about vehicle-to-vehicle communications and just the risk that might be associated with that? So any comments, even Doug or Jose or Scott?
Okay, yeah, well, I can start. When you're talking about vehicle-to-vehicle communication, there's always two things that we have to consider. Near vehicle communication, where vehicles are sending information to every other vehicle that's out there. US is a lot ahead of the rest of the world because there's already a standard in place. It's not widely used because it's not a widely used technology for now, but it's already thought of. Then you have long distance or vehicle to cloud and cloud to some other service provider, and then to vehicle again, like traffic monitoring and stuff like that. There are millions of different protocols and security measures already in place for other places in industry, ranging from SSL to TLS and all of those kind of technologies that are already in place. And so I think on that specific case, I guess that automotive will use the standards that every other industry is using. On the other one, yeah, it's something that still needs to be properly thought and vetted because there are different technologies still in place, like 5G or simply Wi-Fi, or there's not even a standard protocol or standard medium in place at the moment. So still something to be developed.
Yeah, certainly actively managed and pursued, and a lot of options there as you described. Okay, so this is from Lewis. Do you believe state-level security should be concerned with the implementation of backdoors or kill switches to prevent the usage of remotely controlled vehicles in coordinated attacks against property or other drivers or pedestrians? So I guess generally, um, should we be concerned about such backdoors? We've seen backdoors in other industries and what that can do. Doug, any thoughts there on backdoors in automotive and what state level actors might be or national security professionals might be thinking about?
Well, I think if the
Should we have them or not? Yeah.
I think the history of the last 30 years of hacking, counter hacking, shows us that things go most wrong when we underestimate the audacity of our attackers. That is the biggest grotesque mistake we can make. And it is easy to say no one would ever go to those lengths, or that's far-fetched. And way too many times we let that knee-jerk reaction take off the table something that an attacker thinks, well, I could do that. And yes, I could stitch that together. So, you know, is it, scenes from movies where autonomous cars are getting controlled in fleets and things like that? Is that, you know, out of the realm of possibility? Absolutely not. In my opinion, it's absolutely in the realm of possibility. And would, the attacker that did it would, might even displace Mitnick in the mind of, hacker lore. So, like, I absolutely think it's possible, and I do think that it is appropriate for us to figure out how to keep um, that kind of adversary in mind. But I also think, do I think that attacker would do that just for the lulz, as some say, or just for the fun of it? I don't I don't think so, because something that audacious and that big actually does take a lot of resources. It's not, and it does take a lot of resources and a lot of time and a lot of very specific expertise. So the attacker that does that is going to have several very powerful cyber assets and cyber weapons at their disposal that, another adversary would use in a way that's much more valuable. Surveillance or other targeted things. So if they had assets like that, I don't think they would be blown on a joyride. I think they would be used very, very deliberately, which is actually more dangerous in my opinion. So I do think it's appropriate for us to contemplate that kind of will of the attacker and never let audacity, tell you, it can't be done.
And should the OEMs put a backdoor in for with a kill switch?
The controversial topic. The
I think
libertarian in me says no. The engineer, maybe there could be a use case for it, right? It's these pros and cons of it's one of those, even the technological topic of, yeah, how much how do we engineer technology so it also gives a person maximum freedom, personal freedom versus government control. That's a whole nother aspect. I don't want to go down that rabbit hole, but the aspect of, is there a use case for a kill switch? Possibly. I know that's come up in some of the U.S. based laws that the Congress has been discussing. Again, personally, could that be misused by a nation state, whether that's intentional or through a hacking event? Yeah, it's possible. And I think what Doug is saying about, attacking critical infrastructure like vehicles on the highway, it's something you have to think of those impacts and really consider if somebody's sitting on how long could they sit on an exploit like that too before an OEM patches it. That's an interesting to think about as well. If you go to all this effort to develop it, how could an OEM detect it and then also patch it from there?
Yeah, here's another question from the audience. So what are the main challenges, in your opinion, OEMs are facing regarding the compliance with UN R155?
Okay. Well, I would say that we can split the OEMs there in two categories: the traditional OEMs and the new challengers. Traditional OEMs have a lot of problems in supply chain management and continuously updating their vehicles or their fleets. Newcomers have typically been better in these scenarios because they typically have a lot less supply, a lot smaller of a supply chain. They do a lot more vertical integration, and that's good in reaction time and the ability to continuously update their vehicles. That's the biggest
Very good.
challenge right now.
Yes, another question from the audience, which is similar to the vehicle to vehicle, but we have to keep in mind that it's an extended environment in which software-defined vehicles and autonomous vehicles are operating. So not only are there other vehicles, but there is other infrastructure at play. So with the rise of smart cities, are there any additional considerations with communication between, or vehicle to infrastructure communication that we need to consider? Maybe a follow-up to the V2V one, but this is vehicle to infrastructure. Any additional considerations folks have for that level of communication involved in the connected vehicles ultimately?
Well, I think in this case, like the V2V, we're still in a very early stage of deployment of these kind of technologies. But we can already see potential adversarial attacks coming up with, like the colloquial example I gave earlier of the guy with the stop sign T-shirt. But there's also been stories about a guy that fills a shopping cart full of Android phones and creates a traffic jam on Google Maps that people use to navigate. So there's a lot of opportunities there in those kind of adversarial attacks to abuse the infrastructure. This is before there's actually infrastructure, vehicle to infrastructure, infrastructure to vehicle communication. So I can see the potential for it.
All right.
If I could add on,
Please.
Vehicle to everything kind of communication, the security layers start at you start at the hardware. You have a private key that gives you your private identity in that system. No one else knows that, but then you also have a PKI system that there's a public key infrastructure that's going to vouch for your identity, that you're an authentic communicator in this network of vehicle to infrastructure. And then you're sending those messages. If somebody is hacked, if a vehicle device is hacked that's sending somehow malicious messages, you can revoke it through a revocation list. So a lot of these things are tackled with these vehicle to everything type engineering standards. I know that these things have been thought of, even privacy attacks of like, okay, so how do you de-anonymize the actual identity but still authenticate it? So I can't just track, similar to like on your Bluetooth device, how it tries to switch its MAC address, so you can't track the MAC address around. How can you or it's addressed? How can you do that again in vehicle to everything communication? That the engineers are thinking of these things. Not to say that there aren't holes, but they are thinking of kind of the major security gaps.
And just as a follow-up to challenge that a bit, Scott, because this came also from the audience, and I think it's kind of the next layer of discussion. If over time with quantum computing, the long-term security of such things as HSMs and RSA, might be vulnerable, are there any additional considerations for us to think about today to ensure security over, whatever that time period is to Q day?
My guess is that both the cars that are rolling today and the cars that are in the current design life cycle will not, most of them will not still be on the road when an attacker is able to dedicate time to, when there's so much quantum computing power that they've been able to move down the stack of utilization of their cryptography and crypto breaking capabilities down to intercepted communications from 10 years ago regarding someone's vehicle to vehicle activity. So I think it is, so again, one guy's opinion, but I think it's absolutely appropriate to contemplate that the crypto algorithms getting used are, quantum resistant, but and those standards are being set. But I think it's improbable that many of the vehicles on the road today will still be there when there's so much excess quantum computing power to target my car.
Yeah,
Excellent.
but just to add on that, there have been periods in the past where there have been vulnerabilities found in the cryptographic algorithms that basically random they're useless, and so that comes back to the topic that we gotta be prepared to update things continuously, because it would be essential if any of these kind of cryptographic algorithms to be broken, to be able to change the possibilities of that we can protect the information there.
Very good. Thank you. Well, we didn't quite get to all the questions. We will offer some follow-up offline on any remaining questions. We are at the top of the hour, so I just wanted to thank Scott, thanks Jose, thank you, Doug, and of course, Olivia for producing this panel and for the panelists participating. As mentioned, if you're interested, attendees of this webinar can have a free risk reduction analysis with your software. Please just send me an email. But with that said, I think the landscape, with all the safety requirements, the distributed supply chain, the changing nature of software on vehicles, the rise in connectivity, and just further advancements in technology demonstrate that automotive cybersecurity is a serious business. And there's a lot going on in the space. If you haven't checked out the Auto ISAC, that's a great source for vulnerabilities, but also any of the panelists today. So thank you, Scott. Thank you, Jose. And thank you, Doug. And thank you to the audience for joining us today.